So these are the notes that are going to go along with your 9.3.1 assignment. So please make sure that you have the blank copy of the notes printed out so we can follow along and highlight as we go and fill stuff in as well. So the directions up at the top kind of continue along with what we've already been doing. So with a system though, so we're doing a system of two variable inequalities this time. Basically, we're just putting two of them on the exact same coordinate plane. That's ultimately it. So just as a reminder for the boundaries, which we talked about on the last video, and then the big difference here, though, is what we're looking for in this case now is we're looking for the overlap of the shading. That's going to represent the solution to the system. So if we take a look at our examples here, and we have a couple of them to do, we're just going to take a look at one at a time. Put them on the graph. So start with the first one, complete it all the way through, have the graph, have the shading, and then go back to the drawing board on the next one and begin all over again. So I'm going to go ahead and color code these because I think that might help a little bit. You are absolutely welcome to go ahead and just do them in pencil. And at the end, if you want to color code, you're welcome to, but you do not have to. So I'm going to take that first one and I'm going to rewrite it with an equal sign, just like we did previously. So I'll do y is equal to negative x plus 3. Okay, I know how to graph that. So I'm going to go over and I'm going to go to my y-intercept of 3 and plot that point. And then, because I'm not totally sure where the graphs are going to overlap, I want to make sure that I kind of covered the whole coordinate plane if I can, or as much of it as I can. So I'm just going to do my negative slope here. And then I'm going to take a look back at the inequality before I actually connect the dots. And I'm going to determine if it needs to be solid or dashed. And based off of the inequality symbol that I just circled in green, to kind of matching the color that I'm doing, there is no equal to part. So that's telling me that this is going to be dashed. So it's going to have like chunks missing out of it. So if I go through, kind of dash the boundary here. Make sure that it really does look like it's got like kind of holes erased out of it. And then what I want to do is I want to test a point. You choose the point that you want to test. You guys know me. I really like testing 0, 0 if I can. I'm not always allowed to do that. Remember, it has to be the point that is not on the graph itself or on the boundary. So I know that 0, 0 is not. So just put a little mark where it is. And then I'm going to go ahead and plug 0, 0 back in to the original before I got rid of the equal, before I included the equal sign. Okay. So that's just going to give me 0 plus 3, which is 3. And then I ask myself, is 0 really less than 3? And yes, it is. So I'm going to go back over to my green line and I'm going to go towards the 0, 0. So what I'd like to do is I'm going to kind of shade all in this direction. And again, I am going to go all the way through the coordinate plane in the direction because I'm still not totally sure where the other one's going to be. I'm honest with you, I haven't even looked at the other equation yet. Okay, so now let's go to the next one. So I go back to the original. I'm going to color code this guy purple. And I'm going to do the same idea. So I'm going to turn it into an equal sign. So y is equal to 2/5 x minus 4. Okay, I'm going to go ahead and start at 0, negative 4. Oop, let's get rid of that line. So 1, 2, 3, 4. And then my slope in this case is 2/5. So again, make sure that you get enough points on there so that we can kind of go through the size of the coordinate plane that we have. All right, I'm out of room over there, so let's go down. Okay. All right. To those are all my points for the purple guy. All right, I go back, I take a look at the inequality that I just circled in purple. So well back at the beginning, and I see that there is an equal to part. So that means that this guy is going to be solid. So I'm going to go over to my graph. I'm going to connect the dots with a solid line. Okay. Now, I know it can be a little distracting sometimes because you have multiple graphs together. So one of the things that I have recommended in the past instead of color coding is that people do labels at the end of them so they remember which one is which. Or when they're shading, they shade in a specific direction. So you'll notice that all of my green shading kind of started at the green line. So I'll go ahead and highlight it in green so you guys can see what I'm talking about. Kind of start at the green line and then went to the left. So you can see like this trend of shading that's happening. So I didn't just go through and madly just scratching a whole bunch of area. I wanted to see kind of like a motion of the lines. So I can hopefully find the overlap a little bit easier if I shade in a different direction. So in this case, back to my purple line, I see that 0, 0 once again is a decent choice. It's not on the purple line. So I'm going to go ahead and check 0, 0. Plug that back in to the original before I turned it into an equal sign. And then go ahead and do the math. So I'll get 0 is greater than or equal to 0 minus 4. And I know 0 minus 4 is negative 4. So then I have to ask myself if this is true. 0 bigger than? Yeah, 0 is bigger than every single negative number. So then it worked. So here's what I mean by my shading. I am going to start at the purple line, and I am going to kind of not run in the same direction. So I wouldn't graph my purple that way, because then I'm going to have a hard time distinguishing it from the green, especially if I'm not color coded. So what I'm going to do is I'm going to start and I'm going to kind of go in a different direction. So it's almost like I'm creating like a pattern where the overlap is happening. So I can see almost like a little crosshatch happening, or like a grid being created between the shading. Okay, so now I know it doesn't look like much, but the solution's actually in there. The solution is where the shading overlaps between the two. So there's a couple of things that you could do here. You can go through, find where the overlap in shading is, and actually go ahead and darken it in if you'd like. So we can go through and we can kind of darken in this area between the purple and the green. So that's one thing you could do. Or what some people like to do is kind of grab their eraser and they erase the parts where it's not overlapping. So that's another way that you could do this. You go through and get rid of all of the non-overlapping area. That's ultimately up to you. You just need to make sure that when you look at the graph, it is perfectly clear where the overlap is occurring. So let's say you wanted to go through and just shade it in darker. That's okay. You just need to make sure that it is perfectly clear where that overlap is happening. So if we were in class, I would call it the arm test. So you take your paper and you hold it out arm's length in front of you so you're looking at the paper. That dark region should kind of pop off the page at you. So it looks like a separate, or it's a specific region on the graph. And that's it for the answer here. So all of the shading that I left on there is where the green and the purple would intersect. So if you want to, you can go through and kind of extend the green, but notice it's still going in the same direction that it was previously. So we've got another example. Now this one is a tiny bit more difficult. Not a huge amount though, just a little bit. So if we take a look at the first one here, I'm going to kind of do the same thing that I did. I'm going to color code here. I'm going to turn this into y equals. And I'm actually going to shuffle these guys around because I like my x to come first. So 4x plus 6. All right, that one doesn't make it any different other than the shuffling part. So you're going to start up at 6. And then you're going to have a positive 4 slope. All right, we're off the graph already, so we're going to go the other way. And again, I really do like to kind of go through the entire grid, especially if sometimes the shading is kind of far off and it's hard to see. Okay, I go back to the original inequality there. So I'm looking at that symbol. It's got an equal to part, so this guy's going to be solid. So I'll go ahead and grab my solid line for this one. Another thing that you can do is if you forget, and I think I did this in the previous video, to kind of look at it and you're like, oh man, this should have actually been dashed, then you can go through and just kind of erase little pieces of it. That's okay too. Okay. All right, so if we take a look at this, now we need to be able to test a point. Okay, I know you guys know this. I'm testing 0, 0. So I'm going to test 0, 0 right there. I'm going to go ahead and plug that in before I turned it into an equal sign. So back to the original. That's going to give me 6 plus 0, and that's 6. 0 greater than or equal to 6. No, that's not true. That's a definite no. Okay, so I'm not going to go towards that one. I'm going to go away from it. So if I was on the line, kind of right around there, I'm not going to go towards because it didn't work. So I'm going to go away instead. So I'm going that way when I shade. Okay, so I'm going to start and I'm going to go all the way in that direction. So notice I'm still trying to make sure that I'm kind of following my line in a specific direction. So you can kind of see the trend of all of my green lines, trying to create that grid later. Okay, let's take a look at the next one now. So if I take a look at the next one here, this is where I think it becomes a tiny bit more complicated, not a huge amount. It just requires you to do some work with getting it into y equals. So notice I turned it into an equal sign. Now I'm going to subtract my 5x to the other side. So I'm trying to get the slope in the y-intercept. So I want y equals mx plus b. So it's negative 5x minus 3. I'm going to divide everybody by 3 to get y equals. That's negative 5/3 x. And that's going to be minus 1. Okay, now I'm done with what I think is the more difficult part of this question. So it's going to start at negative 1. And it's going to have a negative 5/3 slope. Is that right? Yep. And I'm going to run out of space that way, so I got to go up. All right. You go back to the inequality. Back at the original, looks like it's supposed to be dashed. So I'm going to go through and I'm going to put a dashed line through this guy. Okay, now let's test a point. 0, 0 is awfully close. It makes me a little nervous. So I think what I'm going to do is I'm going to try like, I don't know, like 3, 0, something over there. So 1, 2, 3. All right. That guy, I feel confident is not, I know which side of my line it's on. Now, if your graph is way more accurate than mine, which it should be, then maybe 0, 0 is a choice that makes sense, but I'm not too sure because I didn't use a ruler graphing those, which I should have, but I didn't. So I'm going to go ahead and check 3, 0. Go back up to the original before you dropped the inequality symbol. So plug in your x, plug in your y, and then greater than negative 3. All right, let's see. So it's going to be 15, that's 0. -3, 15 greater than -3. Yeah, that's true. All right, so the purple X, so 3, 0 worked. So I'm going to go towards it. All right, so I'm going to start at the purple. I'm going to go towards the side where 3, 0 was located. Now, one of the things that you can do instead of going through shading everything and then erasing stuff later, if you can see where the shading is going to overlap when you start, then instead of doing extra shading, you can just go through and start erasing immediately if you would like. So as soon as I started shading to the right of the purple line, I knew this stuff that I'm erasing down here for the green wasn't going to work. I knew it wasn't going to be overlapped down there. Now make sure you don't erase the boundary because you still want the green boundary there. That's still part of the answer. Oop, got a little close to the purple one. So again, we just want the overlap between them. So remember, this was one of the options, is that you could go through and you can erase the section where it didn't overlap, or you could go through with your pencil and just darken it in where it does overlap. It's ultimately up to you. You just want to make sure that it is perfectly clear where the answer is. Okay, so that's going to be our solution to this guy. Now moving on, this is a great time for you to pause the video. See if you can do this problem. So that's what I'm going to do. I'm going to pause it. I'm going to work the whole thing out. And then when you're ready, unpause it. And then let's see if we match. Okay, here's the solution to the third question. You'll notice that the overlap in shading just so happens to be all of the shading from the green equation, or the green inequality, so from the first one. Okay, moving on. Another great example, you'll notice that here we have one of those special cases where one of the variables is missing. So again, great opportunity, pause the video, go through, see if you can do the two inequalities and find the solution to the system. I'm going to pause, work it out, and then come back and let's see how you did. Okay, here's the solution for question number 4. Notice that the purple line is solid and the dashed line is also horizontal. So keep that in mind. And I did forget to mark 0, 0 where I tested for the purple. Okay, moving on to the next one. This one's along the exact same ideas of what we did previously. Again, the only thing that probably makes it a little bit more complicated is the type of the equations. So the first one we do have here is exponential, and this was what I was telling you about in the last video. They do tend to get a little bit more complicated. So we've got a change here. We know that we can rewrite this using, the 0th term, but it gets a little tricky now because of that -6. That -6 does things. That -6 is actually where your asymptote is going to be this time. So here, let's get rid of the highlight. This guy is going to give us the asymptote. And remember, the asymptote for these guys is always horizontal, so it's going to be y equals -6. Okay, so if we go over to the graph, I'm going to go down to 6. And I'm going to put a dashed line through, since that's going to be my horizontal asymptote. Now, since the horizontal asymptote isn't at 0, we can't necessarily do the same trick that we did before. What I'm going to recommend that you do is find the Y-intercept. So all I'm going to do is plug in 0 for x. That's really it. So I'm going to plug in x equals 0, just to find another point. So if I do that, I'm plugging it into the equation, not the inequality. 0.5 to the 0 minus 6. As a reminder, anything to the 0 power is 1. And then 1 minus 6 is going to give me negative 5. So I'm going to have the point 0, negative 5. So if we plot 0, negative 5. Okay, now from here, there's a couple other ways that you can do this. You can't, because we need to know what this thing is going to look like. We still have to sketch it. You can either plug in another point. That's totally fine. Or you can take a look at the B value. And the B value is the number inside where the exponent's located. So if I go back up to the original, so the exponent is x, which I just highlighted in yellow. It's the number that the exponent belongs to. So the number that the exponent belongs to in this case is 0.5. 0.5 we know is a half. A half is somewhere between 0 and 1. If the value is between 0 and 1, then that means that your y values are decreasing over time. So since 0.5, so since 0.5 is less than 1, it's got to be positive though, so in between 0 and 1, then I know that my y values are going to be, so if I had like a little sketch up here, they would be starting high on the left-hand side and they would be going down on the right-hand side because because that b value, that number that has the exponent, is smaller than 1. It's going to be shrinking over time. We could do it that way, or you could plug another point in and find another point on the graph. I'm fine with just, okay, I notice that it's 0.5, it's shrinking. So let's have a graph that's shrinking. So I'm going to start, so I'm at my graph now. I'm going to start up on the left and I'm going to hug on the right. And I'm going to have that nice exponential curve. Now, I'm not going to pay attention to right now if it's solid or dashed because I can always go back and erase chunks of it. So I'll look at the inequality in just a minute. So I'm going to start high and I'm going to go through that point. I don't want it to be straight up and down because it is shrinking over time. And then I'm going to go down. And then I can erase the extra little guiders that I put down here. Okay. Now, there's my green graph. Okay, now I'm going to go back up to the inequality. And it's supposed to be solid anyway. So now at this point, I still need to test a point. Okay, 0, 0 is definitely not on that curve. So I'm going to plug 0, 0 back in and see which way I'm supposed to shade. So now we're back to what we did in the previous video. So 0 is greater than or equal to 0.5 to the 0 power minus 6. Okay, that's 1. So 0 is greater than or equal to negative 5. Yeah, that's true. Okay, so I'm going to start at the boundary and I'm going to shade towards that location. Okay, it's kind of inside that exponential curve. So I'm going to start at the exponential curve and I'm going to go inside. Again, still keeping with the same theme of I'm shading, kind of following the same pattern or same direction. I'm not just scratching some shading around. Okay, let's do the next one. Now the next one, again, this one's not so bad. This one's just a line. It can look a little tricky because it doesn't have a Y-intercept that's being shown, which we know is just 0 then. So this is going to start at 0, 0. Whoa, I'm not going to be able to test 0, 0 because I'm going through 0, 0. All right, and then my slope is negative 2. So I'll go down to right 1. Go through and get some points on my graph. look back at the inequality symbol. So back at the original purple guy, it's not supposed to be solid. So I'm going to go ahead and make this dashed. I'm going to make sure that it looks like it's got breaks in the line or little holes. Okay, I can't test 0, 0 because it's on the purple line. So I need to test something that is clearly not on the purple dashed boundary. And I think I'm going to test, I don't know, let's test something that isn't even around it. So I think I'm going to go out here. Let's see where that was. 1, 2, 3, 4, 5, 6, 7. So I'm going to test negative 7, 0. Plug it back into the inequality. So 0 is less than negative 2 times negative 7. And that's going to give me 0 is less than 14. That's true. Okay, so that point does work. So I'm going to shade that way. But I think what I'm going to do, instead of shading all in that direction, I'm just going to try to shade the overlap right now. So starting at the purple line, I would be shading in that direction. Okay, so from the purple line boundary, I want to go below it, but I only want to overlap with the green that's already there. So I think it's in here. So here's a situation where instead of going through and shading everything and then erasing it, I can just go through and shade in the overlap. And I'm not actually going to erase the other green because it's not necessary. So if you take a look now, so if I had this on a sheet of paper out in front of me and I held it out in front of me arm's length away, it would be perfectly clear where the overlap is because that section is way darker than any other shading on the entire graph. Okay, the last two problems that we have, the inequalities have already been created. The graph's already been created. Your job is to figure out what the inequality symbols are that go in. So, but you got to match the equations that go together. So if we take a look over here, we've got this shaded region, and it looks like we had red, blue, and green. Okay, so let's do the red. So I see a red boundary here. Okay. That's not a line. That's clearly not a line. That's a curve. So if I take a look over here, only one of them is a curve. It's not a line. That's the first guy right there. And then I want to look at where the red shading is. And it's kind of hard to see, but we're basically dealing with, well, I can see the red shading right there. So I know that from this red graph, the shading went in this direction. So my recommendation to you to figure out the inequality symbol is, well, and it was solid, so this is definitely an equal to. So I'm back at the red equation. I know there's going to be an equal to symbol in there. Well, I don't know if it's greater or less, though. Choose a point inside that region, and you know it's going to work. So if I take a look, it looks like negative 2, 1 worked. So any point you can think of. Actually, we can do negative 2, 0 right there. That's in the shaded region. So if I go back and I'm going to plug in negative 2, 0 into the red graph, so I'll get 0. I don't know what's going there. That's what I'm trying to figure out. Then I'm going to plug in the negative 2. 0. There's an equal to. I don't know what goes in there. Okay, so then I would go ahead and just grab my calculator at this point and see what this thing ends up being. So if I did 4 to the negative 2 power, that would be 1 over 16. And then 8 times 1 over 16 is going to give me a half. Again, you can just type it in your calculator to figure out what this is. And then that's going to be negative 1.5. Okay, I need to figure out what inequality symbol goes where the red question mark is. So I'm going to highlight it in yellow. I'm trying to figure out where that is. I want this to be true. So it's either going to be 0 is greater than or equal to negative 1.5, or 0 is going to be less than or equal to negative 1.5. But I want it to be true. So for this to be true, 0 is greater than or equal to negative 1.5. And that is the symbol that I'm going to put up inside the box. So greater than or equal to. All right, that takes care of the red one. It looks like we have a blue one up here also. So I'm going to grab my blue pen. And the blue line or boundary is this dashed guy right here. Okay, that is one of the oddball guys. That one is an equation that only has a single variable in it. So that is going to be the next one here. And it is x equals since it's vertical. Okay, so from here, I know that the shading for the blue, well, I see blue over there. So I know that's going to be then to the right. So this is blue shading here. And I'm going to choose a point in this area that works because I want to make the inequality true. And lucky me, 0, 0 was in that shading. Okay, so for the blue, I'm going to plug 0, 0 in. And I want this to be a true statement. So it's going to be 0, question mark, negative 2. Now, if you take a look at the boundary is dashed, so I don't want an equal to part. So then I have to ask myself, what inequality goes in there? So 0 is greater than negative 2 or 0 is less than negative 2? Well, the only one that makes it true is greater than. So I go back to the empty box and I put my greater than symbol in there. Okay, the last one I need to deal with, looks like this guy is green, is the other boundary. And it's not dashed. That guy's solid. So I've got my green boundary there going over in my green line. And I see green shading down in that corner right there. So where I put my green question mark. So that means my shading is down here somewhere for the green graph. And now it's easier to kind of see where the overlap happened. It's that little middle section right there. Okay, what's a point down here that actually works? Oh, 0, 0. Yes, so I'm going to do 0, 0 again. So I go back, color code this guy green, and I'll do 0, 0. Plug this in, so we have 0, question mark, I don't know what goes there, 5/3 times 0 plus 4. Okay, the boundary though was solid, so I know this is going to have an equal to part. So I'm going to go back up to the box and put the equal to part in. Okay, now let's go ahead and work this out. So I'll get 0 question mark equal to 0 plus 4. So 0 question mark equal to 4. Okay, so what needs to go in there? Well, I think it's going to have to be less because 0 is not bigger than 4. So this one is going to be 0 is less than or equal to 4. Don't forget the or equal to part we already put up there. So less than or equal to. Okay, and that's the answer. So we just went through, and by looking at the graph and figuring out where the shading was, kind of look in that region, find a point that worked, plug it in, and then make it work in the inequality. And I have another one here for you. So this one can be a little bit trickier because there's so many things on there. But just so you know, this middle section here, So this section right in there, that darker shading, that's where the overlap is all occurring. So why don't you pause, see if you can figure this one out. I'm going to do the same, pause it, and then come back and see how you did. Okay, so here's the solution to the last one. You'll notice that 2 of the boundaries were dashed, and I color-coded those blue and purple. And then the other 2 boundaries were solid, and those were yellow and green for me. And then I went through and I checked points that were actually in that shaded region with regards to that line, and then tried to make those inequalities true. And that concludes our notes.